Okay, in this example, we're given the cotangent of pi over 2 minus x is equal to 3. And anytime we see pi over 2 or 90 minus x, that reminds us of cofunction identities. So if we make our trig hexagon to help us remember these identities, we always put a 1 in the middle, and then the leftmost vertice gets tangent, and then we use our quotient identity to go around. So tangent is sine divided by cosine, and then we'll use the reciprocals. So reciprocal of cosine is secant, reciprocal of sine is cosecant, reciprocal of tangent is cotangent. And cofunctions, remember, go straight across. So sine's cofunction is cosine, tangent's cofunction is cotangent, secant's cofunction is cosecant. So since tangent is the cofunction of cotangent, we can say that the tangent of x is equal to 3. So we can go ahead and put a 3 there for the tangent, and then use the reciprocal to get the cotangent, which would be 1/3. Okay, now we're going to need a Pythagorean identity in order to find another. And since we've got cotangent here, we may as well continue with that. So 1 squared, which is 1, plus cotangent squared is equal to cosecant squared. So 1 plus cotangent squared x is equal to cosecant squared x. Okay, then we'll substitute in our cotangent value, which was 1/3. And then we'll simplify this. So 1/3 times 1/3 is 1/9. So we'll have 1 plus 1/9. And we need common denominator, so we'll change that 1 to a 9 over 9. And that's cosecant squared x. Then we can add the numerator since we have a common denominator, and we'll get 10 over 9 equal to cosecant squared x. Okay, we're going to take the square root of both sides to get that cosecant by itself, and square root of 10 square root of 9 is 3, and that's a plus or minus. Okay, to decide whether it's the positive or the negative that we need to keep, we're going to look at that acronym, all students take calculus, to figure out which quadrant this angle is located in. So all students take calculus. A, for all 6 trig functions are positive in quadrant 1. S, sine and its reciprocal are positive in quadrant 2. T is tangent and its reciprocal positive in quadrant 3. C is cosine and its reciprocal positive in quadrant 4. We're told in our given information that the sine of x is greater than 0, so sine is positive, and the cotangent is 3, that's also positive. The only quadrant where sine and tangent and cotangent are positive would be quadrant 1. So this angle is in quadrant 1, which means we need to keep the positive. So positive square root of 10 over 3 is the value for the cosecant of x. So we can go ahead and put that on the hexagon. Okay, then we can do a reciprocal to get the sine. So we're going to flip that square root of 10 over 3 upside down, and then rationalize the denominator, and we'll have 3 square root of 10 over 10 for the sine. Okay, then we can use a product identity to get the secant. So secant would be the product of tangent times cosecant. So secant of x equals tangent of x times cosecant of x. We'll substitute in 3 for the tangent, root 10 over 3 for the cosecant. The 3's cancel and leave us with a square root of 10 as the value of secant. And then we can do our reciprocal to get from secant to cosine. So 1 over square root of 10, and then we'll rationalize that denominator with square root of 10 over square root of 10, and that'll be root 10 over 10. And that would be the cosine, root 10 over 10. Okay, and then we have all 6 of the trig functions evaluated.